Sorry for the crude setup. I'm going to try to explain how to use the RC chargers for charging and testing 18650s. This setup here is something I made for being able to just drop in individual 18650s. It's basically just the sense lines off of the balance leads, or the balance leads tied in to each one of these 18650 jacks or battery holders. We have banana jacks that allow it to be, this jig to be reconfigured for like 1S, 2S, all the way up to 6S, of course. For instance, if I only had one battery in this jig, I could remove this jumper, replace it with this jumper here, and then it would only charge and monitor a single battery. Well, actually, it's monitoring all of them at the same time, no matter what. It's the charging part that you have to add this jumper. But this is not exactly what the person on a comment asked about. I was just showing this because it simplifies testing the M18s and the DeWalt lithium battery packs. So as I shown here, we got the jig. This is just a standard RC charger, and it's being powered by a benchtop power supply. So I'm gonna try to clamp this up here and swap out some batteries here. Sorry for the odd camera angle. I'm not a YouTuber. So we can use, I use this jig for, sorry about that. I use this jig for, of course, testing these battery packs. Basically, these jumpers actually mimic the same jumpers that are on, or that are inside of all battery packs. So they actually line up. But this allows me to just take a whole battery pack, drop in there, and then I get the statistics. So basically, this is the way it's wired up here, it's bypassing the PCB in the battery. So we can start a charge here, and you can see it reads out individual cell voltages. We can see the internal resistance. That's going to be skewed slightly, but not much, because of it being parallel to the BMS inside the battery pack. But it is relatively close. it's showing individual charge per cell and how many amp hours it's essentially charged each cell individually, and then a total of all the cells together. But this allows you to run all the tests that you would with a RC battery, but it's doing it on the drill batteries. Of course, you can, if you have other batteries like old nickel metal hydride or nickel cadmium batteries, all of the RC chargers I know of can do all of that. It's still going to be wired up the same. I'm going back into the charge settings here for this. You can, of course, charge it, which is what I just showed. You can also still do I don't ever do a storage charge on these batteries, but you can do the discharge and cycle on these batteries, which sometimes will help fix a dead cell. Or if you have a battery that's acting wonky, you might try, when I say acting wonky, I'm talking about like it won't charge at all. You might balance it first and then go ahead and do a charge on the battery through here, and then you can try putting it on your regular charger. I'd say that works maybe 75% of the time. Normally, whenever you got that problem where it won't charge, there is typically a dead cell in the pack. But if you go to the to start a charge here, like I showed, you get all the individual cell resistance. Normally you're gonna have one or two cells that are like way different than the rest, and that's where I would start as far as detaching the jumpers and replacing that cell, or testing those particular cells independently by removing them out of the pack completely and then stick them back in here, or stick them back in this jig to do the individual testing. So I mentioned in the comment that somebody else requested information on how this all worked or how to wire this up. I know I mentioned magnetic balance leads, but before I get to that, I don't remember if I said at the beginning of the video, this is basically working off the same concept as one of these single cell or 1S charging adapters. These jumpers essentially are the same thing as what these switches are, but that's basically the concept of how this functions. So I'm gonna get rid of that. Plug this in here. I guess we'll just use this DeWalt battery pack to demonstrate how this works. So first you're going to want to figure out your positive and negative sides. So this side's going to be positive because it's got the band. This side doesn't have band. So the first balance lead is always going to be your negative, and strictly negative. And that's just going to go across the jumper there. Sorry, this is wrong. We're looking for a negative with a single strap, no double, just a single. That's gonna be your negative. And then this one up here is gonna be your positive, because it's a band and a single weld strap. So we're gonna work our way down. Yellow is the next one here. That's gonna go on this side across that jumper. And then we got orange is our next one. That's gonna go on this jumper. Then we got blue. It's gonna just kind of go back and forth here. Green's the next one. And then we're going to end with the positive on that. As you can see, we have individual cell voltage. It'll give us individual voltages across, or for each cell, with just the balance lead connected. But I don't think, yeah, low battery voltage. So if you get an error that like that, it's because you don't have a actual power supply connected to each end of the battery pack. So we're going to connect a jumper lead here, which is going to the output of our charger, and to our negative. So now it's reading our total voltage. Now when we start it, shouldn't get that error. So now it'll go ahead and charge the pack just like the other jig did. And we still get individual readings for each cell. And again, if the PCB was still on the back side of this one, also even in the DeWalt ones or any pack, it could skew it. But since there's no PCB on this this pack, these are the right impedances. And this has been calibrated with benchtop NES calibrated equipment, so I'm pretty confident in the accuracy of this now. When I did first get the both of my iChargers, they were pretty close, but they were off slightly. So I would say no matter what brand, especially if it's one of these Toolkit RCs, these need to be manually calibrated for your impedance to work properly. But that's basically all there is to it. Hope that helps.